Hi everyone, my name is Jethro Lobus. I'm a team member of Cohort 1 at Blockfuse Lab, Blockchain Technology Bootcamp, here to share my journey so far from week 1. And today I'll be talking about computer architecture. Basically, computer architecture deals with computer design and implementation of components of computer. Basically, we learn about computer interface like the CPU, which comprises of the memory, arithmetic, logic, control unit, and timing unit. And then we learn about memory. We learn about input and output devices in computer architecture. For the purpose of this session, I would like to talk about memory. Memory in a computer basically is a very important concept talking about computer architecture and also programming. It's a part or a component of a computer that stores information and data. It encodes this data, it stores them, and then it can be retrieved when needed. Every programming language in general have data structure and data types which are stored in memory. So the concept of storage in memory comes into play, and that's the need for understanding what memory is in programming generally. We are able to learn some sections of memory in week 1 when we are learning about data types in Solidity, which is a programming language for writing smart contracts. We are meant to understand how storage works in memory. So we learn about heap and stack, which are sections in memory. I'm going to take them one after the other. But first of all, I will go with stack. Now, stack is a section in memory that stores primitive data types, and primitive data types are called scalar data types in programming. So stack memory basically stores values that their size are known at compiler on time. Is easily accessible. The second one is the heap. I said heap is a section in memory that stores compound data types, which are non-primitive data types. These data types are data types that store the value which the size are not known at compile runtime. The values that are stored can be accessible. So in heap storage, you can access the values by the address references called pointer. Even stack as a memory compartment can be able to access the value that is stored on heap storage. Basically, that is what I learned from memory and storage in Solidity and programming.
So continuing from where my colleague stopped, up next on that is the data storage. On the blockchain, the data storage is used to store the many data or information that comes to the blockchain, and that actually works through the use of the Merkle tree to be able to handle that. We need to understand the basics behind what helps with the storage in that Merkle tree or on our blockchain. That brings me to bitwise operators, which was the next thing we learned about. Bitwise operators are functions that are used to communicate in binary languages. That is the simplest form or the simplest language to which the computer system can understand, which is the zeros and ones. So we have different types of bitwise languages, few of them which are the AND, the OR, XOR, the NOT, the shift right and shift left bitwise operators. What do bitwise operators do basically on the blockchain? Their basic function is one, they help in improving efficiency on the blockchain. How do they do that? They do that by actually compressing the data coming in or onto the blockchain into blocks, because on the blockchain we have something called gas or gas fees which are emitted during a transaction or in a smart contract. So these bitwise operators help in compressing them, and also they are used in cryptography in the sense that they help in running complex calculations in a little amount of time, thereby saving you the stress or the wastage of the time you will need to be able to solve those complex arithmetics. The next thing bitwise operators do is they help in the storage of the EVM. They help in handling the storage aspects of it. Bitwise operators help in hashing transactions that are made, so they will be able to also help in the compression of data that comes onto the blockchain.
You cannot talk about computer architecture without mentioning concurrency and parallelism. Computer architecturing describes the structure of a computer system, which I am very sure that computer architecturing, it enhances the efficiency of a computer. Concurrency is when handling multiple tasks. Multiple tasks, they start and run, and also they also complete at an overlapping time, which parallelism is when multiple tasks occur when the multiple tasks execute, and they execute simultaneously using different cores or processors. The use case of concurrency is more out, okay, let's say like in responsiveness in a computer system, making the computer system responsive. Concurrency have to do with in JavaScript, it has to do with the await function, which you have to wait for the other function to finish before continuing with the other one, but not blocking the whole function. So parallelism have to do with splitting the overload of a work. Let's say like a computer is having a multiple tasks to execute. It splits the work done to different cores or processors to achieve the tasks. The use case of parallelism is when dealing with machine learning and videos, big videos, whereby it have to share the computer have to share the workloads into different cores to achieve the specific tasks. That's more about the parallelism and the concurrency. To learn more about this, you can follow us on the YouTube channel and WhatsApp on the social media channel.